Welcome everyone to the part 3 of the Olas Dev Kickstart. We are really happy to have you for this third day, um, and completely learning about the Mech tools. I will pass the word to David now, and he's presenting his screen. And feel free to raise your hand anytime you want.
Yeah. Hey everyone, welcome again to the last part of the Dev Kickstart 2. Let's start reading the usual disclaimer and presentations as usual. This session is organized by Valerie in order to educate people about Olas and developing autonomous services. Valerie is one of the core contributors to the Olas ecosystem, and all the content we provide here is an expression of our view and therefore does not constitute financial advice. So we are now in the position to start. For all the people who are watching from YouTube and other streaming platforms, we will start by presenting us. Once again, we will do a quick recap of part 1 and part 2, and then we will talk today about the Olas protocol, and we'll finalize with the last lab session about finishing our Mech tool and minting it. Then, of course, we also have a questions and answer session at the end, but feel free to send any questions you have or raise your hand during the talk as well. So let's go with the presentations as usual.
So just in case someone is watching this for the first time, I am Carol, product manager here in Valerie, responsible for the developer experience, Dev Academy, and well, making sure that you have everything you need to learn the whole stack and start contributing code. Being in Web3 for 3 years now, always around marketing, DevRel, and community. Before that, I work in these big tech companies like Google, Facebook, and I'm also a qualified lawyer. And thank you, David.
All right. So you already know me, or most of you already do. I am David B., one of the software engineers at Valerie and founding member of the Olas DAO. And my background is on mechanical engineer, but nowadays I work as a software engineer. All right, with all that out of the way, let's do a recap of what we've been discussing so far for the first 2 sessions. So we kickstarted things on Tuesday with a short explanation on what's the goal of this course. Also, we talked about what is Olas. We made a small introduction to it. We discussed what autonomous agents are, and more specifically, what Mech is and what Mech tools are. And for the first session or lab session, we basically use the Mech client library to send a request to one of the deployed Mechs. And yesterday, in our second lab session, we started building 2 tools, one calculator tool, and then a prediction tool that uses OpenRouter to make a prediction on future events. So today, we will be finishing that and minting that. But before we do that, we need to talk about the Olas protocol. So Olas protocol is basically a bunch of smart contracts that are deployed to several blockchains, mainly Ethereum. And this protocol is composed of 3 different parts: the registries, the tokenomics, and the governance. So registries are a bunch of contracts that handle basically components, agents, and services that are minted to the Ethereum blockchain. Basically, when we finish today's class, we will be minting one of our tools to one of these registries. So registry can be thought of as databases that store metadata information about all the components, all the agents, and all the services that developers all over the world have contributed to the Olas protocol. Then we have the tokenomics part, which are another set of contracts that basically handle the, the incentives like dev rewards, also bonding mechanisms and other economic incentives. So we can incentivize people like you to bring either code or capital to the Olas protocol. And lastly, we have the governance, which is the other part to uh, handle all the let's call it laws or rules that services need to follow or that devs need to follow in order to participate. In governance, we have things like new proposals to change registries, to update tokenomics, to remove all parts of the code on those smart contracts, but also we can propose new things there. So these are the three core components to the OAS protocol deployed to the Ethereum chain. And the most useful facts you should remember about this is that uh, these three parts implement mechanisms to coordinate, secure, and manage autonomous service on chain. The complete protocol has been deployed, as I said before, to Ethereum, and some other functionalities are also deployed to Solana and 6 other EVM-compatible chains. The dev rewards mechanism, which is the most, I think, relevant part for today, is deployed only on Ethereum, and this allows developers to receive rewards for their code contributions whenever a service owner decides that he or she wants to include this code into their services. And all these components that made up agents that can be deployed to services can be registered or minted. And then whoever is the developer that registers and mints these components will receive an NFT that can be thought as of a certificate of ownership of this code. And we can and we will explore this at the front end on registry.olas.network. So after we mint today, we will also explore some of the components that are already minted there. So I think we can now jump to the lab session 3, or last of lab sessions. And if you remember, yesterday we spent some time creating 2 different tools, the calculator and also the prediction tool. And at the end of the class, I showed you that there was some issues with the current implementation. So I was wondering if any of you could have a look at that and could modify a bit or fix the issues. If you have managed to do that, please feel free to jump in and explain what you did. If not, I will go ahead and do it myself. Do any one of you have solved the issues or at least modify the tool? I think someone said so at the beginning, right?
Yeah, I modified the tool. I didn't modify the error message handler, but I did modify the prompt to like force it to better adhere to the response.
Nice. Yeah. The prompt quality is one of the most important things here. Yesterday, I used a very simple one that not every time will work. So this is something that we all know about prompts. If your prompt is like very short or not very specific, sometimes you will find that the LLM ignores your the will ignore the rules that you impose on the output, for example, and you might end in a situation where, for example, you receive, in this case, some response that does not adhere to the JSON format, so you cannot load it, and you will get an error. So let me pull up my VS Code, and this is the script that we were using yesterday to run our tool, and this is our tool. Let's run the tool once again and see whether today it works or not. Maybe it will, maybe it won't. All right. Happily, it doesn't work. So you can see that there is a JSON decode error. And you can see here that the first thing, I mean, I have printed not only, I have printed the result, but also I tried to print the loaded result here. So that's why here we can see that the response to the question, will autonomous agents play an important role on the economy Sunday, is yes, according to the LLM, but the LLM forgot somehow to include the closing bracket here. There should be a bracket, so we can load it using JSON loads. And when we try to load that, well, we get an error, of course. So one way to fix this would be to improve the prompt and test it a lot, but that would take a lot of time. So what I'm going to do is not fix the prompt, but at least fix the handling. So whenever the response is not completely correct, we at least handle that situation. One of the issues that I also introduced yesterday in this tool is that whenever we call the LLM and we receive the, sorry, here, when we get a response from the LLM, we take for granted that we can access to the choices, that there's at least one element, that there's a message there with some content. But this could not be the case. And also, maybe the response, for some reason, I have said, maybe I forgot to add my API key, and the response will be an error. So at least the minimum I can do here is to add some API error handling. What I'm going to do this is check that my response is at least an 200. So for those that you don't know, whenever an HTTP response has the 200 status code, this means that's okay. But if it is different from 200, it means this is an error. I also know that even if I get a 200 okay HTTP response, there might be some other errors inside the body of the HTTP response. So I also want to check whether there is an error in response.json. So this API, this Open Router API, sometimes will include an error field there. So if oops, sorry, I'm missing here this. So in this case, we know there's an error. So here we also need to return this call that we made yesterday. That says, for example, well, we can even do something like this. Let's say that here we can add the response status code, and then colon, and we can share the response.json to see the body. So if this happens again, it will return an error. Let's try this once again and see whether this fails. Well, in this case, the LLM decided to include the bracket, so this worked. Let me try again. Okay, now it's working every single time. All right, anyway, if the LLM had forgotten about this bracket, now we will be handling this. The next part is checking whether all this data is here. And the simplest way to do that is to encapsulate this inside a try except block. So if when I try to access all this data here, which is required, I get a key error, for example, I also will return an error response that says something along the lines, I don't know, we can just return the exception here. And yeah, there we go. Now he is insisting in doing it right, so we always get a good response. But well, if this has failed, we will be handling it here. The last thing I want to fix, this is not purely a fix on the tool, but it's something I think I forgot to say yesterday, is that sometimes, and this happened after the call we had yesterday, sometimes you call a free model. Remember that we are using as a default model the Llama 3 or 8 billion params, but you only can make a bunch of calls each day. So if for some reason you exhaust that number of calls, you won't be able to call that specific model until the next day. And after the call we had yesterday, I tried to make a lot of calls until I exhausted this, and I saw that when you exhaust a specific model, you will be getting a 401 error here. And if this happened to you, you can use another model until you either pay for subscription or it's the next day. So I have here a list of 3. There's more, but I have here a list of 3 different models that you can use for free. So now we can, instead of using the default model, we can specify, for example, if I do this, models, I would be using the same. But if I set this, for example, let's set this to 1, so we will be using Llama.2 from Google. Let's see what happens if I try to call. Yeah, we got an error now, right? So here the response was yes, this forgot the bracket again. So what I'm going to do now is, once again, encapsulate this inside to try accept block. I think it's like this. The code, what is on the code? Let me copy it from here. And I will basically pass on this because there's no way that the tool can guarantee that this will be always complete. So if I get here in the script wrong formatted response, well, I will print it, and then if it fails to load and print, then I will just forget about it. Let me run it again. Yeah, we got an error again, but now we don't get the exception. Now let's try with the last of the models. Sometimes some models are best for predictions. This one worked, but look at this. It's not completely perfect because now instead of an N, it said no. So these are other set of issues that you should be handling on either the script or the tool. Remember that you will be responsible for handling all these things whenever you implement your own tool. So even if there are some issues, I think we can consider this tool to be complete now. So what I'm going to do now is to first, to remember, we need to update the hashes of the tools. The hashes, let's repeat this again just in case, live inside the packages folder. There's this packages JSON file that lists your tools next to its IPFS hash. And also, whenever you go inside a specific tool in the component.yaml, the same hash is here, right? For each file. But I am most interested in this one. So now I'm considering that I like how my tool looks like. So I'm going to mint it. And before I mint it, I need to create a hash and push my tool to IPFS. So I'm going to run autonomy packages lock. Look at these hashes. You can see that this hash has changed because I have performed some changes in the code. And you can see that even if you just add a comment, let's say, for example, like I add a small comment here, keep an eye on the hash again. I'm going to lock again. Bam. There you go. The hash is completely different. This is what makes this tool unique and what can be used to identify the exact code byte by byte. Now that I have my tool already locked, I am going to push it to IPFS. This is you can think of pushing to IPFS as uploading to the cloud, where other people can pull it. So I'm going to run autonomy push all. This will push all my packages. In this case, there are only two tools. So when I run autonomy push all, I might get an error. I hope I get an error. Yeah, there we go. So whenever you push, you might see this error. Please remove all cache files from blah, 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 blah. So before we push, we need to ensure that there's no garbage in the tool folders. But if you are running Python, let me show you. You can see that sometimes Python generates these PyCosh folders, right? So you need to remove these folders. When you forget about this tool will remember you about, so don't worry about that. I think I have another one here, PyCache. I delete it. And maybe I could have another one. Oh, okay. Then I think I removed all of them. So let's push all again. Okay, I forgot that one. Another one in customs prediction request. There we go. Remove. Push again. And now it worked. It says, I am pushing, calculate a request. This is the public ID, and this is the package hash. This hash should be the same as it is here. You can see that it ends in RUE, and the same for the other, for the prediction request, which is the one that we are going to mint now. And this hash ends in F04. So it's the same as this. So now I'm going to copy this hash, because the next step, well, actually, before I mint, let me do another thing that I think is interesting for everyone. So I have a tool or a couple of tools that I would like to mint. Let's focus for today. Let's focus on the prediction one. The next thing we want to do is to actually incorporate this tool to the Mech. So we need to open a pull request on GitHub, so other engineers from Valory can review our tool, accept it, and if that's okay, if the tool is interesting and well-coded, we will integrate it into the Mech, and we will deploy it so other people can make requests to the Mech. Remember that we have been testing this locally, but now it's time to move it to an actual running service deployed. So how we do this, I guess most of you will be already familiar with how pull request or how Git works, but just for the sake of this call, I am going to open a quick pull request, not against the Mech, because I don't want to add garbage PR to the Mech, but I will add it to this Mech tool template. Some people use some Git tools. Some people prefer to do the CLA. Some people use VS Code directly. Today, I am going to use Git tracking, which is one of the solutions I usually use. So I'm going to create a branch and call it, for example, tool prediction request. I am going to add, remember, this is not, this is how I do it, but you can do it other ways, even using the Git client. So I am creating a new commit with my prediction tool. I am going to push this branch to the repository. And now, if I go to GitHub and look for the Mech tool template, you can see that now I can see here that there's a new branch created that can be used to create a pull request. So I'm going to click it here. If not, I can go into pull request and do it from there. But since the green button is already here, I'm going to open a pull request. And here, the only thing I need to do is to write a description of this tool. So this is a tool that makes predictions using open router API. Please review and merge, something along those lines. Now I click on create pull request. So now the pull request has been created in the Mech repository. Remember, you don't need to do this in the against the Mech tool template. This is just for this is an example. You should do this on the Mech repository. So you need to basically clone the Mech repository, copy your tool there, and open the pull request. Whenever you open a pull request, here you will see a list of checks like is your code well written, is the code a lot of different checks and tests that will be run against your code to verify that you haven't done something crazy. One thing that you can do to double check is that the files change look like what you expect. So what I have changed in this PR is basically some hashes in the packages.json, and I have changed several files. These are the changes that I implemented today. But in your case, this will be at least three new files: the init file, the Python file, and the YAML file. Once you have opened this PR, you should tag here someone for review. So I am going to add here, for example, Jose. I don't think he's here, but then I don't know if I can add myself. Well, let's add Carol, who is in the call here as a reviewer.
I am here.
Yeah, but you don't appear in the repository, I think. I'm just adding Carol here. So now Carol will be notified. Don't worry, this is just as an example. Now Carol will receive a mail from GitHub saying, okay, you have to review this pull request. And then, yeah, once the reviewer in the Mech, usually this is Artian, once he reviews the pull request and maybe there's something wrong, he will add some comments or ask for some changes. Once he is happy, he can merge, and then he will deploy the tool to the Mech. And from that point on, anyone can make a request to your tool. But this is only half of the work, because we have now coded our tool, we have now integrated the tool into the Mech, and some engineer from Valory has deployed it to the Mech. Anyone can use it, that's great. But now it's the good part, which is being able to receive some potential rewards. And for that, you need to mint your tool. That means registering it to the Olas protocol and setting yourself as the owner of the tool. Today, we are going to mint this tool, not on mainnet, because, usually minting means that you need to pay like a couple of dollars, maybe $1, maybe $3, depending on how the gas is on mainnet. But since this needs to be minted on Ethereum and it's not very, very cheap, what I'm going to do now is I'm going to create a fork using Tenderly, and then I will use that fork to mint against the fork. So for those that you don't know Tenderly, if you go to tenderly.co, lets you do this. So you can create a free account on Tenderly, and whenever you are logged in, you can come here to virtual testnets. And inside virtual testnets, you can create a virtual testnet. Virtual testnet is basically a fork, so a copy of the Ethereum blockchain or the blockchain that you decide, where you can basically do whatever you want for free. So I'm going to create. Here I'm going to select mainnet for Ethereum, and this is the Mech testnet for me. I'm going to call it like this, and that's it. I can already click on create, and now I have this link here, this RPC here, that I am going now to use to mint. Once you have a virtual testnet, another thing that you want to do is, for example, create some fake Ethereum that you can spend. So what I have done is basically use this button here, which says fund account. So you click here, you put an amount, like I want to have, I don't know, I want to be rich and have 1 million ETH, or sorry, no, this is here, 1 million ETH for me. And here you can paste your wallet address. You can basically get one from MetaMask, and then once you paste here the address, you can send. For example, I'm going to send here. You can see that I haven't already doing some tests, so I have 100 Ethereum already, but I can copy this and send to this address a lot more. So I can click on fund, and that's it. Now I have 1 million ETH. I have done so not in this virtual testnet, but in the other one I created earlier today, which is where I sent 100 ETH to me. So if you are using MetaMask, what you can do, I don't know, are you able to see MetaMask on my screen, or is it invisible? Because I'm not sure if this is shared or not.
Yes,
We
we
can
can see
see.
MetaMask.
Oh, okay, perfect. So what you want to do when you open MetaMask is to add here a custom network. You click on add network, then add network manually, and here you can call it Mech. What was the name? Mech testnet. Here is where you paste the RPC you get from the Tenderly. Here, this you copy this, you paste it here. Then you set chain ID to 1 because that's the ID for Ethereum. The currency symbol is ETH, and that's it. You click on save, and then you add a custom blockchain, which is actually a fork. So I have already done so, and that's why here now, when I click here, I have Tenderly Ethereum, which is where I added my 100 ETH. And now I can use this to mint and try things without actually spending any money. To mint, you want to visit the Ethereum registry, the Olas registry at registry.olas.network. Here, you can select any chain, but we are focused on Ethereum because, as I said today, the dev rewards are only available for Ethereum. We could be minting components, agents, and services. But today we are minting a Mech tool, which is a type of component. You can see there's a lot of other components. There's a lot of other people who has been minted other components. And to mint, we are going to click on mint here, and we need to fill in some metadata. The first thing is who is the owner of the component that we are minting. For this, I am going to copy from MetaMask my address because I want to set myself as the owner. The other thing that we need to fill is the metadata. This hash is not supposed to be filled in by you. What you need to do is to click on generate hash on file in this button here and fill in some data. For example, the name of this component will be, we usually follow the following format. First, it goes your name, for example, Valerie or David B or whatever, and then the name of the component, which is prediction request. And you can set whatever you want on the description. Then you set the version. If you remember, the version is also set here in the packages.json, but also in the component.yaml. So use that number. I set it to 0.1.0. So I put it here, and now I need the hash. Once again, I go to the packages.json. I'm going to mint this component, the prediction request. So I copy this hash and look at how every hash always starts with BAFYBEI. So whenever you are going to set the package hash, there's a drop down here that lets you select between two different formats. This is the one, the BAF is the one that we are always using for components. And now I can paste my hash here. We have an error, right? Because what I have pasted already includes the BIF, so I am going to remove it from here because it's already in there. Now it's correct. And optionally, I can link an image to my NFT. Today, I'm going to skip this step, but if you want your NFT to show an image, you can push an image to IPFS, get the hash, and here you would do this: IPFS : / and here your image IPFS hash. It will be a hash similar to this one, but here for the image instead of for the code. But I did not push any image to IPFS today, so I'm going to skip it. I have all the metadata in place now, so I can click on Save File and Generate Hash. And a hash has now been automatically calculated and set here. The last thing is to add the dependencies. Luckily, for Mech tools, we don't usually have any dependencies. Other types of packages like skills, connections, contracts, and so on, usually rely on other packages. For example, if here if we were minting the Mech agent, the Mech agent has a lot of Mech tools as dependencies. So here we would be adding the token IDs for all of these dependencies. But today we are minting a tool that has no dependency. So I will leave this empty. Now I can click on Submit. I am prompted to pay for this, and the cost of this minting would be $1.16. I click on Confirm, and bam, component minted. This was really fast because remember that we are running against a fork. If you are minting against Ethereum, this could take 20 seconds or 30 seconds or something around that. You just need to wait for the transaction to be mined, and then you will see the same message of the component minted. Since I have minted this against a fork, we won't be able to see this on the registry. But let's have a look at other components to see what they look like. For example, here, Victor yesterday added the DALI request. So it seems like it's a Mech tool for sending requests to DALI and generate images. So this is his address. This is the hash. So when I click on the hash, this is the hash that we generated a few seconds ago with all the metadata that shows the name, the description, the code URI, the image, which is empty in this case, and some attributes. You can also click on the name itself. No, sorry. Oops, sorry. Let me go into view. I think we have some issues here. Let me change my RPC just in case this is the front end being confused. And I'm going to change into the actual Ethereum and reload this. Yeah, that was it. Sometimes the front end can get really confused if you are connected to the fork. And now I wanted to see actual components minted to the real network. So yeah, I needed to change that. So whenever you click on view inside in a component, you can see here the name, the description, everything. You also can see the claimable reward and the top-ups that I will cover in a second. And here there are two links, the hash and the code. The hash is the same thing I opened a few seconds ago. Whenever I click on the code, this brings up to the IPFS gateway that Olas is hosting. So this is basically like a file explorer. So when I click here, you can see the three files that compose your tool: the init file, the components.yaml, and the Python file that implements all the code that we have been implementing yesterday and today. So this is how people can access to the code, check that what you have minted is exactly what you say, and so on. Now, let's say that you have minted your component. Whenever you go into the registry, you can click on My Components, and here you should see your newly minted component. And once someone finds your component or your tool interesting, for example, let's say that you have coded a really good Mech tool. You have merged into the Mech, and it has been deployed. You have minted it. Now, if the tool has been merged to the Mech, at some point, the Mech agent here in the registry will be updated with your token ID. Here, the token ID is shown at the top bar, at the navigation bar. This is 223. This is the ID of this token, of the DALI request. You will have a different one because this is unique for each token, for each component. So at some point, if the Mech has found this useful, it will integrate this number as a dependency. And from now on, each month or each epoch, let's say dev rewards usually run for a month, more or less. Sometimes it's a bit more, sometimes it's exactly a month. So during each epoch, people can donate to services. For example, maybe I find the Mech very useful and I can donate 0.1 ETH to the Mech. So this donation will be split between all the components that are dependencies of the Mech. So if your tool has managed to go inside the Mech and be merged there and deployed, then you will receive a part of the donation at the end of the epoch. That, remember, it goes for something around a month. And at that point, you should see here a small amount of Ethereum that you can claim at the end of the epoch, and that will be your reward. On top of that, if the one that donated to the service also has locked, I think it's like 10,000 Olas into Olas, so this person has a lot of voting power in the network, then the Olas protocol itself will top up your donation in it with a bunch of Olas as well. So you could see that you not only receive Ethereum, but also receive some Olas as reward. And this will happen every month from now on forever. I think with that, I covered all what I wanted to explain. Let me go to my slides again and see whether I forgot anything. Yeah, I think that's all. Let's go with questions. Do we have some questions? How can you make your own Mech client? What do you mean, your own Mech client? Your own Mech client library? Or not sure what this question means, Richard. Yeah. So yeah, I think I know what you mean. So we have been making the request ourselves, like manually using the client. But yeah, as we explained on the first day, not only humans make Mech requests. Usually are agents the ones that make requests automatically. For that, we have another academy coming at some point. That's not covered here, but yes, there's a lot of agents. If you want to have a look at an example of an agent that makes Mech requests, I recommend you going to GitHub and looking for the Trader, which is the most popular agent service out there. So either you go with the Trader Kickstart, which is basically a simple and quick way of running the Trader, or if you are more interested in the actual code, the Trader implements a bunch of skills that make Mech requests, but this, yeah, we don't have time today to go through this. This is another level of complexity. So yeah, if you want to do that, either wait for the next academy about coding agents, or maybe start having looking at the docs that we have on docs.autonomous.network. Also, you can have a look at these repositories, and for sure, you can always ping us with specific questions on Discord on the dev support channel. What else? Have you managed, Peanut, to fix your issue? Not sure what the issue is, but I see some conversations there. Okay, could you maybe send me a message on Discord with the specific things that you are trying to achieve and what you are doing, and I will happily help you there, because it's not clear to me by reading your messages what you are trying to do. All right. Is there any other question or something that I'm missing? Oh yeah, local inference. So yeah, yes, we actually have some agents that do local inference. Of course, to do that, you either need a really powerful GPU if you want to run serious models like, I don't know, Llama 3, the big one. But there's another agent, I don't know if you know Tsunami, that Tsunami does some inference at the CPU level using small models like the Llama 3, the 8 billion parameters, the same that we have been using for our test on this tool. You can do that, and yeah, there's already packages for that. Yeah. So basically, there's two ways of doing things. You can either do it locally, or if you don't have the power to do that, then you can send a make a request. That's what why the Mech exists, because not everyone has the willingness, the money, or the GPUs to do that locally. Someone here gets a failed transaction. Yeah, this is the same error from the other day. Did you update the gas? What is the name? The gas environment variable? Did you try it running? I think it was export Mech X gas limit, and we set it to 200,000. Did you try this? If okay, try with that. If not, try with a slightly higher number. Where are you running this? Is this no? This should be run on the terminal, not on a script. You should do it like this. Here, example, I can do export before you run your script. I think it's Mech X gas limit equals 200,000, and now you run the script it was like Mech X interact blah 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 blah. In PyCharm, under Windows, or are you in Linux or Mac OS? Windows, yes. Yeah, that's a really good idea, Richard. Set it, instead of doing it by using the terminal, you can do it from PyCharm. Try that as well. If that does not work, ping me also in dev support channel in Discord, and I will take a look at that. Not sure why it is not working. All right. I think we can wrap it up. Caroline, floor is yours.
Yes. Yes, thank you. Thank you very much for the session, David. Thanks everyone for joining for these 3 sessions. I know it's a lot to learn. And this workshop series that we call Kickstart, they are focused on Mac tools, and we feel it's the easiest way to start learning playing with our Olas stack. Now, we do have Academy, which is more complex, focus on building agents, requires a lot of knowledge and experience as a developer, like as for experienced developers. And if you or anyone here is interested on that, message me on Discord as well. We don't have any dates for a public launch, but we are running on the background for a small amount of developers interested. So if you are one of them, ping me and we can talk and see if this other program would suit you as well. And then about the Mac tools, as always, you will receive uh, the follow-up mail, and this time there will always also have a feedback form. I would really appreciate if you could fill the feedback form. One of the questions there is if you had the time to build a Mac tool. So I know that you need a few more days to do that. But if you can complete this feedback form until the end of next week, it would really help me and help us as a team to understand what worked well, what didn't work, and how we can improve for future workshops. Uh, James, I'm seeing your question here. Yeah, if you go to the rules channel, you will be able to react with some emojis to get a role. The builder role is the one specific for developers building your Olas. If you can't, just tag me there. Yeah, that's all. Anyone? Any other questions? Can we wrap up, finish?
One last thing I would like to say is that now we encourage you to try to build your own Mech tools, of course. Then, so if you can think of an LLM or some new exciting tool that you have seen there, for example, we have just seen this one from Victor to call DALI, I think it was. So if you see a new LLM or whatever, just go for it. Make a tool that makes a call to one of these APIs, try to get it merged, and then, yeah, you will get some nice rewards.
Yes, and we are also aware that the concept of dev rewards is not very easy to understand, and that's why another reason that we are running these workshops is that you have the chance to build your first Mac tool, and with this chance to start experience and the rewards by yourself, and then I guess you will understand how it works. It might be a good surprise.